Okay, so here we are on station 620, temperature control. So this is just on the other side of where the experiment 610 is. So halfway through the lab period, one team will be on 610, one will be on 620, and then you guys will switch halfway through. So you'll be able to calibrate and characterize the input sensor, and then characterize the output, the final control element. So the final control element on the temperature control experiment is this circulation heater that you should recognize from the unit operations lab, because we use them on both continuous stir tank reactor experiments to control the inlet temperature. Now, the way you did it in the unit ops lab was using a power controller. That's a manual device. And you're going to do the same thing in this lab, but it's because we need to characterize this element, find out how much power causes how much change in temperature for our system. And that's going to be important to know when we program our controller. So first thing I want to check is that I have water flowing through my device before I turn on any power with the power controller. So let's get the water flow going. You're going to have this valve closed so that we're not have water going in the sink through there. And right now we have going to the flow meter. And you can vary this flow to whatever you want within the range of the flow meter. And that's going to affect how much power you need to change the temperature, of course. And so that's what you have to understand, is that with certain flow rates, you're only going to be able to control the temperature to a certain limit because there's only so much power that the heater can put out. And so you'll need to kind of explore what your range of control is going to be with this final control element. So one thing that is different from the unit operations lab is that we have this power meter inline here that reads the power being supplied to the final control element. And we change this units to watts. So it will display watts for me. And this is set to 0. I'm going to turn it on. And I can set my power. And so you have a thermometer that measures the input temperature. And at different power settings, you'll see how much it actually changes the temperature of the device. And so that's going to be important, like I said, for calculating the gain of the final control element, and that's going to be needed to program the controller so it can make a control decision about how much power to send to your final control element to change the temperature. And so you can do it for various flow rates. You can't change the inlet temperature, but you can change the flow rates and see how that affects the performance of your final control element. And you can also try different power settings. Okay? And so when you're done, though, this is very important, safety-wise. You want to make sure you set your power controller to 0, turn it off, and only then turn off the water supply. Basically, when you come in to do this experiment, I will have the water flowing through this system, so there will be about 100 milliliters a minute, very low water flow going through here. But I don't want you to touch this at all. Don't turn off the water flow until the end of the lab. It's very important because otherwise this can get very hot on the outside. It can become very dangerous. So of all the experiments in here, I would say this one concerns me the most, just because if you have power going to the heater and you have no flow going through there, it can become dangerously hot. So that's something that you need to think about when you're doing this experiment as opposed to the other experiments. Thank you very much.